Today we're going to learn about proportional relationships and how that relates to graphing. How does a graph show proportional relationships? Things that you'll need to know: proportional or non-proportional. If two quantities are proportional, then they will have a constant ratio. If the ratio is not constant, the two quantities are said to be not proportional. This is big. If you look at a graph, you will know that a graph is proportional if it goes through the origin, 0, 0. The graph will always be in a straight line. So if you see a crooked line on a graph, it is not proportional. You can always write the constant ratio in the form of y over x, y divided by x. And when you reduce or divide to find the constant ratio for each. Whenever you get that value, it is also called the constant of proportionality. And you will see this again, most definitely. In order to tell from a table if there is a proportional relationship or not, you can check to see if the ratio y over x is the same. Now let me further explain that. Here you have your value. If we were to actually draw a coordinate for this here, this would be your x is 5 and your y is 10. Just keep that in mind what x and y are. If we were to plot that on a graph, we would go over to the right 5 and then up 10. Now to find out if this is a proportional relationship, all of these coordinates, we can figure out the value of y over x, y divided by x. If they are all the same value, that constant value, then they represent a proportional relationship. And when you draw it on the graph, you will see that it is a straight line and they go through the point 0, 0 if you keep drawing it. So let's find out. We have y over x. So our y is 10 and our x is 5. 10 divided by 5, this is 2. Let's do the second one. Y is 16. 8 is our x. 16 divided by 8, there we go, I told you the answer. The answer is 2. Constant so far. Here, y is 20 and your x is 10. 20 divided by 10 is 2. Our y here is 28. Our x is 14. What's 28 divided by 14? 2. Alright, one more. 42 divided by 21 is also 2. So yes, this does represent a proportional relationship. If y over x and every coordinate in the table is equal to the same value, it does. Okay, let's try this one here. Here, our y is 2 and our x is 0. Well, if you know anything about fractions, this is undefined. You cannot divide anything by 0. The 0 can be on top, but it never can be under. It does not give you an answer. Here we have 8 divided by 3. You can always use your calculator if you would like. And you will get 2.6, and it is a repeating decimal. We can go ahead and stop this problem. We already know that these two are not equal. They do not have a constant ratio. They do not have a constant of proportionality. So they are not. If you want to continue and fill in the chart, you can. 12 divided by 5 is 2.4. Still not equal. 20 divided by 9 is 2.2. All very close, but not the same. And 22 divided by 10 is also 2.2. They are the same, but we still do not have all the values being equal in the whole table. This graph will not be linear, it will not be a straight line, and it will not fall through 0, 0. Okay, looking at this, what we've learned already, which represents a proportional relationship, we can go ahead and cross out C. It is not a straight line. Everything else is a straight line, but another thing that you need to know about a proportional relationship is it goes through the origin. It goes through the point 0, 0, and that is answer A. A represents a proportional relationship. In our last example, we're going to do exactly what we did in the table. To find out if it represents a proportional relationship, you have to take the y and divide it by x and see if it has the same value. So checking out here, remember that the first quantity is your x, the second is your y. So let's find out the constant here. It is going to be 4 over 8. If we were to reduce that, we would get to 1/2. This is as far as we can reduce the problem. So here is our constant of proportionality. Let's see if they all fall in the same. Here is our y over our x, which can also be reduced to 1/2. 5 is half of 10. Looking good so far. Over here, we have our y of 2.5 and our x of 5, which is once again, 2.5 is half of 5. It can be reduced to 1/2. And if our last one is also reduced to 1/2, it does represent a proportional relationship. So here we take our y over our x, and yes, it can be reduced down to 1/2. Try this one on your own and do not forget your summary.